Hi, my name is Charles Kaplan. I'm a professor at the State University of New York at Old Westbury. And in this video, we're going to talk about our friend, the chain rule. And we're going to use it to differentiate some functions that we're not able to use the product rule, the power rule, or the quotient rule on. So let's take a look at one of them. Here's an example of a function we can't use either of those other three methods of differentiation that we've learned up to now. So let's say y is equal to 2x minus 7 cubed. So what we're going to do is we're going to think of this as two different functions. We're going to think of this as an inside function and an outside function. So for example, if this were let's say y equals x cubed, then y prime would be 3x squared. And we're going to use that principle right here to differentiate this function. So y prime, let's think of this inside part, this component 2x minus 7, as just a separate thing. So a separate term. So we're going to bring down a 3, we're going to multiply by 3. 2x minus 7. We're going to reduce the exponent by 1 and make it 2. And we're going to multiply by the inside derivative, by the derivative of the inside component, which if we go down here, say f of x is equal to 2x minus 7, then f prime x is equal to 2. And that's what we're going to do here. We're going to multiply by 2. Let me make this a little bit nicer too. Okay. Therefore, we have y is equal to 6 times 2x minus 7 squared. And that's it for the chain rule for this particular function. It's a relatively easy process to go through. Think of this as just, we could think of this as differentiating some function with two different steps. Part A, we're going to take 3 times this thing, reduce it by the exponent by 1 and make it 2, and then we're going to multiply that by the derivative of the inside component, which in this case is 2. And I'll move this up a little bit, so it's 6 times whatever in the inside term squared, which in this case is 2x minus 7. So that's one example of the chain rule. Let's look at a second example of the chain rule. Let me move this down. How about, we'll make this f of x. We'll put a little chain rule thing up here. Chain rule. How about f of x is equal to 3 times 4 minus 9x to the 4th. So this is just a little bit harder because we have the constant term in the front, this coefficient 3, but that won't pose a problem. So we have f prime of x, our first derivative. Well, we're going to take the 4, bring it down in front, and multiply it by the 3. So we have 3 times 4 times, and then here's the inside component. We're just going to rewrite it. 4 minus 9x. We're going to reduce this exponent by 1 and make it a 3. And now we're going to multiply by the derivative of the inside term, which is negative 9, right? Let me just go down here a little bit. If we took, let's call it g of x equals 4 minus 9x, well then g prime of x is equal to negative 9, and that's what we've got over here. So, f prime x is equal to 3 times 4, which is 12, times negative 9, which is negative 108, times this inside thing, 4 minus 9x cubed. And that's how we do the chain rule on this particular problem. This was not part of that particular problem per se. Let's look at a third problem. How about, well, let's call this chain rule again. these problems can be fun when when you know how to do them. They're not a big deal, and they go very, very quickly. How about y is equal to, how about the square root of 1 minus x? There we go, get some root problems in here. So now what we're going to do is we're going to rewrite this. Y is equal to 1 minus x raised to the power of 1/2. We need an exponent up there for the chain rule. We just can't use this square root symbol thingy-majig. So now we differentiate this just like any other problem. Y prime is equal to, we're going to bring this half out in front, multiply it by 1 minus x in parentheses, and now we're going to reduce 1/2 by 1. So a half minus 1, or 1/2 minus 2/2, right? Let me bring that out here. A half minus 2/2 is negative 1/2. So negative 1/2 is our exponent. And we're going to multiply this by negative 1, which is the derivative of the inside term, right? If we had f of x is 1 minus x, then f prime x is negative 1. So we can rewrite this now. Y prime is equal to, well, negative 1 times a half is negative 1/2 times 1 minus x in parentheses to the negative 1/2 exponent. Now, let me move this up a little bit more so that I can be sure you can see. All this negative exponent does is it says, hey, kick this thing down into the denominator. So let's do that. Y prime is equal to negative 1/2 times 1 over the square root of 1 minus x. And then we can do the multiplication here. So y prime is equal to 2 times the square root of 1 minus x, and we'll put negative 1 in the numerator. And that's it. I mean, this was almost more work. This is a perfectly acceptable answer right here for the first derivative. And we burned a couple extra steps and brought it down into this form. I don't know which form your professor will want. You'd really need to talk to your professor for that. By the way, I'll just give you a little tip. If you're inputting this into one of these online homework problems, you're almost certainly going to have to do it in this form right here. Okay, this is what you're going to need to do. This is probably the way that you would do it in that. There's no real good way to do it like this. And some of these systems, you can, as a professor, we could set them up to accept certain ways of input and reject other ways. And, you know, I leave it on the loosest setting, but they're still problematic. The online homework and testing programs are not perfected yet. So let's look at another problem, the final one in this particular video, and I'll have another couple of videos after this, I think, also on the chain rule. So how about if we work on, how about y is equal to the cube root of 9x squared plus 4. How about that? Well, again, we're going to need to rewrite this and get rid of this root thing. So y is equal to 9x squared plus 4 to the 1/3 power. So we have a fractional exponent. So let's differentiate this guy using the chain rule. Y prime is equal to, and let's see. Well, we're going to take the exponent and multiply everything by that. So we have 1/3 times, and here's the inside part. We're just going to repeat that here. 9x squared plus 4. And the exponent, just like if we were using the power rule, we're going to reduce it by 1. So it's 1/3 minus 1. Well, 1/3 minus 3/3 is negative 2/3. And then we're going to multiply this by the derivative of the inside guy. Well, the derivative of 9x squared plus 4 is 18x. So that's actually the derivative, although that's probably an unacceptable way to turn it in. 1/3 times 18x is, well, let me burn one extra step. 18x over 3 times 9x squared plus 4 to the negative 2/3. Move it up a little more, and here the 18/3 just becomes 6, so y prime is equal to 6x times 9x squared plus 4 to the negative 2/3. The negative exponent tells us, hey, kick this thing down into the denominator. So let's do that. Y prime is equal to 9x squared plus 4 to the 2/3. Remember, we have a negative 2/3 exponent up here, but when we kick it down into the denominator, it just becomes 2/3. We don't put the negative 2/3 there, because if we did, what that would be telling us, well, this denominator is 1 over this thing to the 2/3. So don't make that mistake. When we move the negative 2/3, the term with the negative 2/3 exponent into the denominator, you don't need to repeat that negative sign down here. If you do, it would clearly be wrong. And then we have 6x in the numerator. Okay, so there's the first derivative of the cube root of 9x squared plus 4. This is the first video of probably 3 that I'm making on the chain rule, and we'll be working on more complex problems as we go forward. This is Charles Kaplan. I'm a professor at the State University of New York at Old Westbury, and I hope this video was helpful to you, and I hope you take a look at the other ones that I put up here. Bye-bye.